Welcome to the course E8005 Special Electrical Missions Permanent Magnet Brushless DC Motors. So here in this section we'll be dealing with the permanent magnet materials used. Okay. So at the end of the section one can able to understand what are the materials we can use it in the permanent magnet for the proper magnetization of the brushless DC motor. So neodymium iron boron has the highest energy product of all the commercially available magnets at room temperature. It has high resonance and coercivity in the motor frame size for the same output compared with motors using ferrite materials, but it is costlier. So but both of the above stated magnets are sensitive to temperature, and care should be taken for working temperature above 100 degree for every high temperature applications. Alkino or rare earth cobalt magnets must be used. So here the BH loop is used for understanding the characteristics hysteresis loop as shown. So material x-axis magnetizing force and y-axis it is the magnetic flux density. An unmagnetized sample B is equal to 0 and H is equal to 0. So if a sample is not magnetized, so we can consider B is equal to 0 and H is equal to 0, and therefore it starts from the origin. So here in this the curve OA, if it is subjected to a magnetic field, magnetic fixer, then B and H in the magnet follow the curve OA as the external ampere turns are increased. Curve AB, if the external ampere turns are switched off, the magnet relaxes along AB. The operating point depends on the shape of the magnet and permeance of the surrounding magnetic circuit. If the magnet is surrounded by a high permeable magnetic circuit, that is if it is kept, then its poles are effectively shorted together so that H is equal to 0, and then the flux density is the value or point resonance. Maximum flux density that can be retained by the magnet at a specific temperature after being magnetized to saturation. So here in this the curve BC, external ampere turns applied in the opposite direction causes the magnet's operating point to follow the curve from B through second quadrant to C. In this, so the curve CD represent the ampere turns are switched off at C, the magnet relaxes. Now magnetized in the opposite direction, and maximum flux density it can retain when keyword is minus BR. The entire loop is usually symmetrical and be measured using instruments such as hysteresis graph. So next one, it is the demagnetization curve. In the absence of externally applied ampere turn, the magnet operating point is at the intersection of the demagnetization curve and the load line. The slope of the load line is the product of mu0 and the permeance coefficient of the external circuit. In a permanent magnet, the relationship between B and H is B is equal to mu0 H plus J.